NASA discovered how to create a warp bubble. Light-speed travel is real. Our universe is a vast place, and there is still so much left to discover. Exoplanets, remote galaxies, enormous black holes, and brilliant stars are the things that make up this universe. However, in order to go through this vast cosmos, you have to find an efficient way to travel, which will help in covering longer distances. The billionaire and CEO of SpaceX, Elon Musk, wants to settle humans permanently in space, and other private space organizations are working on more efficient means to travel through space. Unfortunately, even with the most powerful rocket, it is very difficult to travel for longer distances. It might take months or even years to visit our nearby planets. From this observation, we understand that the major problem in space exploration is not time or technology, but distance. Hi guys, welcome back to Science Faction. Before we jump into the video, make sure you have smashed the subscribe button and hit the bell icon so that you never miss out on any of our videos. The nearest star in our universe, Proxima Centauri, is about 4.5 light-years away. This distance implies that it would take 4.5 years to reach the star if you could achieve the speed of light. This is equivalent to 8,000 years of regular traveling through intergalactic space, which makes it impossible to reach Proxima Centauri by regular space travel. So staying close to Earth and its nearby surroundings does not only make sense, but it's basically what we're limited to, unless there is a new mode of transportation. By using warp drive technology, it is possible to travel space in a much shorter span of time. Warp drive technology, however, was doomed to remain a science fiction concept until scientists recognized that such an engine was actually viable. Let's take a step back to understand what a warp drive is before we get any further into what this warp bubble may mean for space travel. The warp drive is a Star Trek-inspired futuristic technology that has relatively little in common with current space travel. Not only would new technology be required to achieve this sci-fi future, but it would also need to violate one of nature's most fundamental laws, which is the speed of light. The key resides in two of Einstein's major publications on special and general relativity, published in 1905 and 1915 respectively. According to Einstein, the speed limit of the cosmos is the speed at which light travels at velocities approaching 300,000 kilometers per second. The passage of time will change relative to an observer. Another is that space and time are linked together in a fabric that ebbs, flows, and bends around mass, dubbed spacetime. This curvature is gravity. A warp bubble might move down this pathway and ride the space-time fabric in such a manner that its relative time remained sluggish, despite traversing huge distances faster than the speed of light. However, the bubble we are talking about must be encased in negative energy such that it produces anti-gravity. Unfortunately, that's not something that can be easily created in a lab. The concept of making warp bubbles isn't new. It was initially presented in 1994 by Mexican scientist Miguel Alcubierre, who nicknamed them warp drives in reference to the Star Trek sci-fi series. He came up with a hypothesis that shook the scientific community. While doing his PhD research on Einstein's general theory of relativity, Alcubierre did some calculations and laid the foundation for an article that appeared in the Science magazine later that year. Until Lenz's findings, it was considered that the only method to make a warp drive was to generate massive amounts of negative energy potential through the use of unknown exotic matter or dark energy manipulation. In Visualization, Alcubierre outlines how we can compress space and time in front of a spaceship and extend it back behind the ship, requiring you to travel a considerably shorter distance to your intended destination while safely locked in a torsion bubble. To solve this challenge, Lenz devised a previously unknown geometric structure of space-time, from which he derived a novel family of solutions to Einstein's general relativity equations known as positive energy solitons. Though Lenz's solitons appear to comply with Einstein's general theory of relativity and eliminate the necessity for negative energy, space agencies are unlikely to develop warp drives in the near future, if at all. One of the reasons is that Lenz's positive energy warp engine necessitates a large quantity of energy. According to Lenz, a spacecraft with a radius of 100 meters would require energy equivalent to hundreds of times the mass of Jupiter. He goes on to say that in order for this demand to be realistic, it would have to be decreased by around 30 orders of magnitude to match the output of a contemporary nuclear fission reactor. Lentz is also looking at existing energy-saving techniques to determine whether the amount of energy needed may be decreased to a manageable level. Another recent study on the problem is presented in an approved publication by Advanced Propulsion Laboratory researchers Alexei Bobrik and Gianni Martir, who discuss their calculations in classical and quantum gravity. The duo offers a generic model for a warp drive that incorporates all extant positive energy and negative energy warp drive schemes, with the exception of Lentz's, which likely constitutes a new class of warp drive spacetime. However, a Lentz-type warp drive is similar to other warp drives in that it is a shell of ordinary material at its core and hence subject to Einstein's cosmic speed limit, which concludes that there is no known technique of speeding a warp drive beyond the speed of light. According to Dr. Harold G. Sonny White, space warp is one of two loopholes found in general relativity theory by theoretical physicist Miguel Alcubierre, since it permits one to travel arbitrarily vast distances in arbitrarily short intervals without ever reaching the speed of light locally. For example, reaching Proxima Centauri in a month as measured by spacecraft clocks and mission control clocks. Well, in order to understand how the warp bubble works, scientists actually created a warp bubble in a lab. Though the study was speculative, the authors admit this in the publication. Nonetheless, multiple initial drafts of the report presented the information inaccurately. As a result, numerous stories claimed that the new finding indicated the genuine, real-world creation of a warp bubble. White and colleagues were looking at something called CASIMIR cavities for DARPA when they found something that looked suspiciously like a warp bubble in their calculations. The CASIMIR phenomenon, which causes magnetic fields to fluctuate, might be the source of the answer. In a nutshell, the CASIMIR effect is the attractive force of fluctuating magnetic fields that pulls two objects together in a vacuum. Electromagnetic waves flow constantly, even in a vacuum, but only a few tiny waves can fit between the two objects. As a result, the total vacuum energy between the items becomes less than the outside energy, attracting them together. During such interactions, negative energy may be formed on an extremely tiny scale. Dr. White stated in an interview that his team has done some numerical studies to come up with an actual structure that could be used to create and manifest a real warp bubble. He said the whole idea of real and analog is meant in the framework of scientific jargon, denying the lab's creation of a warp bubble. Yep, that's all for today's episode, guys. Do you think we'll be traveling at warp speed sometime soon? Let us know in the comments. Don't forget to like, subscribe, and hit the bell icon. See you in the next one.